So in this lesson, we're going to be looking at group 0, the noble gases. So to start us off, what I would like you to do is to draw and write the electronic configurations for helium, neon, and argon, the first three elements in group 0, the noble gases. And then once you've done that, I want you to tell me, in terms of their electronic configuration, what do all three of these elements have in common? So for our first element, helium, we should see that it is in period 1, so it's only got one shell, and it's only got 2 electrons. So it's just going to have 2 electrons in that shell. Neon is in period 2, so it's going to have 2 shells, and it's got 10 electrons, so it's going to have 2 in the first shell, and then 8 in the second. And then we have argon, which is in period 3, so 3 shells, and argon has 18 electrons, so 2 in the first shell, 8 in the second, and then 8 in the third. So if we were to write those out, so helium you would just write 2, neon you'd write 2, 8, and argon you'd write 2, 8, 8. So what you'll notice is they don't have the same number of electrons in the outer shell, and despite the group being called group 0, they don't have 0 in the outer shell, and on some periodic tables you're going to see this group called group 8, but that doesn't work either because they don't all have 8 in the outer shell. However, what they do have in common is they have a full outer shell, because helium only has one shell and the maximum for that is 2. Neon has 2 shells and the maximum for that outer shell is 8. Argon has 3 shells and the maximum for that third shell is also 8. So yes, they don't have the same number of electrons in the outer shell, but they all have a full outer shell. And that is why they are all in the same group. So here we have a summary of information about the noble gases, and again notice how they called it here group 8. So sometimes it's referred to as group 8, sometimes it's group 0, but it doesn't matter as long as we know that it just means they have a full outer shell. So some information that we have, we've got the relative boiling points of the noble gases, so you can see the trend in boiling points. So as we're going down the group from helium to radon, you can see the boiling points are actually increasing. We can see the colors when they are ionized. So all of these are colorless gases, but if you ionize them, so you pass an electrical current through them, then they actually glow different colors. Now you can't see the colors because this is printed black and white, but I'm sure we're familiar with neon signs, so that's all glowing red color. And in the table on the next page, I've filled in the colors for you so that you can see what colors they're going to be, but that's only when they're ionized. As just a normal gas, they are going to be colorless. We've got some uses of the different noble gases, and we have some information about how abundant, for example, hydrogen is, being the most abundant element in the universe. So what I'd like you to do is to sort of read through this information and use it to complete the table at the top of the next page. So in the symbols, the boiling points, the uses, and then answer these questions. So we'll start off with the chemical symbols. We can very quickly and easily get that from the periodic table. So we've got helium, He, neon, Ne, argon, Ar, krypton, Kr, xenon, Ze. Remembering that if there's 2 letters in the symbol, the first one's always a capital and the second one is always lowercase. And also notice that they are all single atoms. They're not He2 or Ne2. They're not diatomic like the halogens were. So these are monatomic. Okay, so the noble gases all exist as single atoms. So we've got the colors when they're ionized. So if you pass an electrical current through them, these are the colors that they will glow. but without doing that, they would just all be colourless gases. So let's have a look at the boiling point. So the boiling point of helium is minus 269 degrees centigrade, so it becomes a gas at minus 269 degrees centigrade. Neon minus 246 degrees centigrade. Argon minus 186 degrees centigrade. Krypton minus 152. And xenon minus 107. So what we notice is that these values, even though they're all negative, they're increasing. So the boiling points are increasing, and that's simply because the atoms are getting larger. So when it comes to atoms, or when it comes to molecules, the larger the molecule, the higher the boiling point. So because these are getting larger, the boiling points are increasing. So let's look at the uses. So helium, obviously we have helium balloons, but that's quite a wasteful use of it. Actually, helium is used to cool MRI machines. It has some really valuable uses. So we use it as a coolant in MRI machines or MRI scanners. It's also used to cool the Large Hadron Collider at CERN. So neon, well, obviously we have neon lights, but we also use it as a coolant as well. Argon. So argon we used to use in old-fashioned light bulbs, the ones that used to have the metal filament. Not many light bulbs use that anymore. But the point was that metal filament, if that light bulb was full of air, the metal filament would react with the oxygen in the air and become a metal oxide, and then it wouldn't conduct anymore, and then it would be no good. So the actual bulb, the glass bulb of the light bulb, was filled with argon because it's very, very unreactive. So it would stop that metal filament from reacting. So we used to use it in light bulbs. It's used in lasers. And it's also used as a fire extinguisher. And again, all that happens is it's the same way a carbon dioxide fire extinguisher works. It basically displaces all the oxygen, and that stops the fire. Krypton, we use it in camera flashes. And xenon we use in medical imaging. Okay, so you're unlikely to be asked all of these uses, but certainly uses of helium, neon, and argon you could potentially be asked about. So the questions: what does monatomic mean? They exist as single atoms. So they don't form molecules. They exist as single atoms. How would you describe the reactivity of the noble gases? They are very unreactive. And the reason why they are unreactive is because they already have a full outer shell. They have no need to lose or gain electrons. If we look back at the alkali metals, the reason they were so reactive was because they were losing electrons. And the easier it was for them to lose electrons, the more reactive they became. And then when we looked at the halogens, they were reactive because they were gaining electrons. And the easier it was for them to gain electrons, the more reactive they were. Noble gases, they already have a full outer shell. They have no need to lose or gain electrons. So they're just very, very unreactive. And the name we give that is inert. We say that they are inert, they are unreactive. So what happens to the size of the atoms as you go down the group? Well, the atoms get larger. As you go down the group, there are more shells, the atom gets larger. What happens to the boiling point as you go down the group? That also increases. Why does it happen? So the larger the atom or molecule, the larger the boiling point. What can be said about the outer shell of each noble gas? It is full. So helium can only hold 2 in its outer shell, and it has 2. Neon can only hold 8 in its outer shell, and it has 8. Argon can only hold 8 in its outer shell, and it holds 8. Which is the least dense noble gas? That is helium, which is why we use it in helium balloons, because it's lighter than air, so it's got a lower density than air, so it floats. And what does inert mean? It means unreactive. Right, for the final time then, we've got 10 questions here for the facts test covering the entire topic of atomic structure in the periodic table. You have 5 minutes, so that's 2 questions you need to answer every minute, 10 questions in total. Off you go. So question 1, why are the noble gases so unreactive? Because they have a full outer shell. What is the appearance of bromine at room temperature? It is a reddy brown liquid. Remember, this is pure bromine. Don't be confused by bromine solution. If you put bromine in water, then it's obviously that orange solution. But liquid bromine is a red-brown liquid. How many electrons does an ion of calcium have? So it's an ion, so we just need to look at calcium on the periodic table. So grab a periodic table quickly. Calcium has 20 protons, so it will have 20 electrons. It's a metal, so it's going to lose electrons, and it's in group 2, so it's going to lose 2, meaning it's going to have 18 electrons, which would make it calcium plus 2. What charge ion do group 2 elements have? Well, we just stated that. Group 2 elements will be plus 2, because they have 2 electrons in the outer shell, and they're going to lose both of those to become positive 2. What is the relative charge of a proton? They are positive 1. How are elements in the modern periodic table arranged across a period? Increasing atomic number, or you could say proton number. Either one is fine. How many protons are in an isotope of chlorine-37? Now again, it's an isotope, but it doesn't matter because we are talking about protons. And in isotopes, the only thing that changes is the number of neutrons. So it doesn't matter that it's an isotope. We're looking at chlorine, 17 protons. How many neutrons are in chlorine-37? Now that is different. So we know that the mass number is 37. We already know that the atomic number is 17, giving us 20 neutrons. What is the link between period number and atomic structure? Period number is equal to number of shells. And finally, what is the relative mass of an electron? It is 1 over 2000. So it's 2000 times lighter than a proton.